Hello, today we're going to get started with our rational numbers unit, and the first thing we're going to talk about is decimals. Okay, so you should be on the 3.1 notes page, and compatible numbers is our vocabulary word of the day. Okay, the textbook definition for compatible numbers says numbers that are close to the given numbers that make estimation easier. So that's how the textbook defines it. I'm just going to make a side note here and just say it is numbers we can use for mental math. Okay? So the most common place that we see decimals is with our money, and sometimes it's very important that we have an exact, accurate answer. But there are also opportunities where we can round. Like when I'm grocery shopping and I try to keep a total of how much I'm spending, I would definitely be rounding that as I go. So I kind of ignore part of the decimal pieces. So the first part on example 1 here, we're going to practice our rounding to the nearest integer. So vocabulary word from last week, integers mean I might see some negative numbers. Alright, so let's start with negative 9 and, that's a decimal, 916 thousandths plus a positive 12 and 4 tenths. So I have two integers here, and it says to round to the nearest integer. So when I do that, that means I'm going to look at my ones place value and then look behind it. So if I'm rounding 9 and 9 tenths, well, that's really close to 10, or negative 10, because that 9 tells me to round up. So negative 10 over here. On the 12, I look behind it and I see a 4, and 4 is less than 5, so that tells me I round down to the positive 12. Alright, so now I have my two integers, and I'm ready to sing my song. So same sign, add and keep, different sign, subtract. Keep the sign of the higher number, then you'll be exact. So I have different signs, so I subtract to get 2, and since 12 is my higher number, it is positive 2, and I have just rounded to the nearest integer. Alright, next it's your turn, so I'm going to give you a problem, and you're going to solve it on your own and check back in. So I have 37 and 2 tenths plus 25 and 83 hundredths. So try that on your own. Okay, good job. It looks like we ended with a 63. Now let's go down to example 2 to look at multiplying and dividing. Okay, I went ahead and wrote a little note down here that I want you to copy on example 2. I wrote, when multiplying, round to the nearest integer, or if you want to make your life really easy, you can just round to numbers that are easy to multiply. Okay, so some numbers that are compatible and easy to multiply are numbers you like to multiply by, like maybe 2, like if you like to multiply by 2, and 10. 10 is a really popular number to multiply by because all you have to do is add a 0. So if it's close to 10, round it to 10. So let's go ahead and take a look at an example. If I have 8 and 9 hundredths, and I want to multiply that by 28 and 32 hundredths. Okay, that would be a lot of work to line those digits up and multiply, move my decimal. That'd take me a while. So we're going to use our compatible numbers. So 8, that's just too close to 8 not to round it to 8. So I'm going to go with that. Now I don't know that multiplying 28 times 8 is necessarily considered a mental math problem. So I'm not going to use 28, even though that's the nearest integer. I want to use something that's easy to multiply by. Okay, we talked about 10 ending with a 0. So what about 30? It ends with a 0, so all I have to do is add a 0, and I know 8 times 3. 8 times 3, and then add a 0. So I made that super easy on myself using compatible numbers. Okay, let's see if we can find compatible numbers with division. Okay, on the other side, we're going to talk about dividing. I wrote another note I want you to write down. So when dividing, we're going to estimate two numbers that will divide without a remainder. Okay, so it's going to be very helpful if you know your math families, and think of numbers that will divide evenly. So I'm going to give you an example here. So 41 and 9/10 divided by 6 and 391 thousandths. Okay, so how would you estimate these two numbers so we could divide without a remainder? Okay, I went ahead and used 42 because 42 is a multiple of 6. So I knew it was going to divide evenly. All right, good job. Let's go ahead and look at our story problem down here on the bottom. They're wanting us to use U-pick. So let's go ahead and fill that in, and then I'm going to let you solve it on your own when it comes to implementing it. So let's read it. Murray and 4 friends. So that looks like important information that I need to highlight. Split the cost of a pizza, with each paying the same amount. So that means if we're splitting the pizza, I know I'm probably going to have to divide. Okay? Murray has $3.36. The cost of the pizza was $14.20. Does Murray have enough money to pay his share? About how much is his share? So since it says the word about, that means I can estimate, which is good. So with Murray and his 4 friends and this understanding, a common mistake is people use the 4, but since Murray is also eating pizza, we have to consider him too. So 5 friends are dividing up pizza. So 5 people are splitting pizza. Split cost of pizza. Yum. Okay, so that's what I'm trying to figure out. And does he have enough money? All right, so picking a strategy, we are probably going to estimate, right? So we are going to round to make sure we have enough moolah. So in the implement here is where we're going to show our workspace. So remember, Murray and his 4 friends are splitting the cost of the pizza. So that's a division problem. So we're splitting the cost 5 ways. So we have 5 people sharing the cost of the pizza, which was $14.20. All right, so as far as the estimating goes, I think we're good with the 5. We don't want to change that. But what are we going to estimate the $14.20 to? We want a number that's easily divisible by 5. So something that's close to the $14.20 would be $15. Another number that I need to round is the $3.36. Okay, because remember we need to know if Murray has enough money. So let's go ahead and round that number as well. So he is at $3.36, which is, we're going to round it down to $3. Okay, so what I want you to do on your own is set up a division problem. Tell me what numbers need to be divided here and what number has to go first. So try that on your own. All right, so it looks like we have to take the cost of the pizza divided by how many people. So 15 divided by 5 is 3. So that means it's going to cost about $3 to buy each part of the pizza or each share of the pizza. So $3 is what we estimated Murray to have. So I'm going to say yes. Hopefully Murray has enough money. And about how much is his share? He will pay about $3. Pay about $3. Awesome job.